Hi, everyone. My name is Itamar Haim. I lead the engineering groups for Red Hat Virtualization, Satellite, and Container Management.
Hi, my name is Federico Simoncelli, and I'm managing the container management team within Red Hat.
Hi. Thank you, everyone, for coming to the last session of the last day and not running off somewhere else. I want to switch. That worked. Can you please, with a show of hands, how many of you are familiar with CloudForms? Nice. OpenShift? Okay. So I'll breeze through those because apparently you all know these parts for the intro of both of those, and we'll have more time for the other part, which is how we integrate the two together. So you probably saw different variations of this slide before. We started with bare metal. We used to have servers. Everyone knew what's on them. Each one of those servers had a goal. Then the age of virtualization started. Server virtualization, consolidation, an order of magnitude more of problems. VM sprawl started. We had many more VMs. Then we decided it might be a good idea to take each virtual machine and look at each service running in it and separate it to its own entity with the age of services or microservices, another order of magnitude problem. So instead of VM sprawl, we'll get to container sprawl. Two tools to solve that. One is on the orchestration and running side, Kubernetes, OpenShift to manage the runtime. The other on the operational management side, CloudForms, which allows us to handle, basically was built kind of to solve the VM sprawl, and we're leveraging that to solve the expected container problems as well. Doing that by providing unified management, so we don't look just as container. Containers are part of the story. In CloudForms, we have the virtual machines the OpenShift nodes run on. We have the hypervisors. We have the storage. We have the network. We have the middleware. Okay? All of those are managed or in phases to be managed by CloudForms. So we get a holistic view of what's going on and the ability to create operational policies across entities from those different layers. So CloudForms started from virtualization, focused in the beginning on VMware, added Rev, added OpenStack, added Amazon, Azure, Google platform to it, so covering virtualization, private cloud, and public cloud. Now we added the containers to it. We're also, as I mentioned, adding the middleware on top of that. So if you were to the session yesterday on the approach by the JBoss team, they're going to add into CloudForms the middleware management, and this will let us drill down between those entities in CloudForms later on. That's the management side that gives us the ability to do our operations and governance and policies in a single place. The other side is the consumption side, the user side. So this is the operational side. The user side, we'll get to that in a second in CloudForms. CloudForms gives us a dashboard, one that comes out of the box. You can create your own dashboards, look at different type of, basically whatever is of interest to you. Is it the top 5 VMs, the top 5 hosts, top 5 pods, capacity, storage, network, whatever you care about that in your organization is creating an issue for you, or you can create different dashboards for different personas, different use cases. The storage guy wants to look at one thing, the network another, etc. Then you can drill down into entities, get a lot of information about those entities, and most importantly, their relationships to other entities. So it's easy to navigate from one place to another through the entities that you look at. You can create your own policies. So when Shell Shock came out, you want now to scan what is going on in my environment, how exposed I am. Because CloudForms has an inventory, you can enable it in a mode that scans your inventory. So it will hold all the information on all the RPMs, for example, in all the system. You can easily create a policy just to get an analysis of what is your current status across all of your inventory. And you can do it for anything that you want until scanning tools will be updated to scan for that, erratas will come out, etc. You can easily do it on your own, and you can do it for anything you want. You can also extend it to scan for other things, configuration files of your choice. Okay? CloudForm is a platform. You can always use it to do more that comes out of the box, which is what we know you need to do what, to handle your own case, your own workflow, your own automation, etc. Similar to that, you can create your own alerts. It comes with tons of alerts out of the box. You can create whatever alerts that you want based on log, metrics, entities, events, etc. And based on those alerts, you can trigger simple actions like SNMP and email, but you can also trigger automate code, which will actually go and fix issues. Various utilization reports, timelines, a lot of information that can help you troubleshoot, see what's going on, etc. in your system. That was the operator side. Another side of CloudForm is the user side, the consumer side. CloudForm abstracts all of the infrastructure, all of the entities, and allows you to expose them as service catalog item to your users. This gives you things like RBAC, role-based access control, tenancy, quotas, approval workflow, and the ability to provision those services to the different managed cloud virtualization, whatever. This is how it looks from the user side. You create services, and each user has permission to provision them. Then they will ask to create such a service, which can go for an approval workflow, integrate with ServiceNow, different things like that, and populate a CMDB with something that got changed, trigger tickets, and then we'll actually provision that service for them. This is the upcoming service designer that's being worked on for the next version of CloudForms, which will allow you to design those services with a nice drag and drop. So you'll be able to pull this service is comprised from 5 virtual machines, run this Ansible playbook on them, provision this storage, and hopefully what we're working on also ability to do OpenShift templates as well as part of that story. That was CloudForm. Any questions on CloudForm so far? Okay. OpenShift side, so OpenShift, Docker, sorry.
How does CloudForm and Satellite, how are they playing together? It feels like they do a lot of the same thing.
Well, they're doing provisioning, which both of them do provisioning. CloudForm focuses more on the provisioning from the workflow and policy side, and Satellite focuses more on the part of the provisioning, integrating with your infrastructure, with your bare metal, with your DHCP, PXE, things like that. CloudForm supports provisioning bare metal through Satellite. Satellite also handles your content, your configuration management, and aspect that CloudForm don't solve it. Satellite is more focused on the system management side, and CloudForm more for policies and governance and provisioning at a higher level on top of that. So, OpenShift. Docker is create a very simple packaging format to package your application and run it as a container on RHEL in our case. Kubernetes brings us the orchestration of running those containers on the different, in pods, basically. The OpenShift adds to that the use case for the developer. We talked about CloudForm for operational use case and CloudForm for the user, the consumer. OpenShift also adds that the part of the developer, the ability to create projects pointing to Git repos, doing source to image, pointing to a Git repo, changing something there, doing the continuous integration pipeline. Hopefully you saw the amazing keynote demo yesterday. If not, recommend to go see it online at what you can do very easily with such tools to get from source to running image, pushing into the registry. So it gives you a full set of tools to create a runtime environment and a developer end-to-end story into that runtime.
That's a single.
Okay. So very briefly, OpenShift. You log into OpenShift. Different projects. You can create a new project as a developer. You can go to an existing project. Inside that project, you see the different entities that you have in it. Those could be services, routes, pods. Services represent the relationship between portions of your application, abstracting the pods. This is a service pointing to a Postgres pod. And we can drill down into the pods themselves. This is in the realm of a single project. All of those entities will go to the Postgres pod. Inside the pod, from the UI as a developer, I can see the container running, the storage associated with this pod. It's a database. It needs persistent storage. Look at metrics online interactively. The logs of my Postgres database all from here. And I can SSH, basically, open a terminal and run commands inside that container running. For routes, routes represent the entry points for external users to access my applications. So again, all of this is easily exposed in OpenShift for the user. This is the topology of my project. So all the entities and their relationship inside my project, the pods, the services, the routes, etc. One last thing, Cockpit. Cockpit is the next generation, basically, administration interface for RHEL host. It's a web-based admin, things you could do in the CLI, command line, but you don't necessarily knew all the commands and where to find them, are just now easily visible in the web admin of RHEL host Cockpit. Similarly, all the various GTK utilities like that you had for storage management, network management, all of those are being basically redone in Cockpit and being phased in through the lifecycle of RHEL 7 to do various administrative operations. So we're going to focus on CloudForms, but after you found an issue, CloudForms will help you identify that you have an issue. If you want to go and interact, like SSH into that machine to look at that, we're going to integrate Cockpit, so we'll be able, from CloudForms, to easily go into a specific machine and leverage Cockpit to do the various stuff. Cockpit is lightweight. It's just a browser. It's not a management system. It doesn't have state. If you're changing the host name here in Cockpit, it actually changes the host name. If you look at logs, everything is very ad hoc, just a nice visualization way to look at things.
Great. Thank you. So we just saw a video, and I saw some people moving forward to see it better. Feel free to move further because we have some other videos coming. Now that we saw how the developer is happy with OpenShift from the developer side, we want to make also the operator happy, integrating CloudForms with OpenShift. So I would like to start showing you a video that gives you an overview of what is the status of the integration. So this is our dashboard in CloudForms for OpenShift. As you see, you have a glance, all the metrics that are collected, all the entities up there. And at first glance, you can definitely find what are the nodes that might have an high load or that might be in trouble. You can go into project. You see all the projects transparently all over the various providers. You can filter them by providers if you want. Then you can travel through the relationship, as we just did with OpenShift. Here as well, you can travel through all the relationships, but not only about the project that you own. We can travel also to the nodes and see what are the nodes where the pods are running and the underlying infrastructure over there as well. We collect the metrics, and those metrics you already saw in the dashboard. But we're not just collecting these metrics for pods, we are collecting them for nodes as well, because we have the visibility of the infrastructure, and we do accumulation of high-level entities such as services, projects and replicators so that you can identify projects that are high demanding in resources. So this is an accumulation of all the pods in I think a service. But anyway, it's also for projects and replicators. We collect all kinds of entities from OpenShift. We have builds, for example. You can see what is the status of the builds that are happening in your cluster. You can go to the pod that actually realized that build. There are another couple of things that I want to show you. One is the fact that we have the dashboard also for the single provider, so that we have all the data just for that single provider. You can connect CloudForms to multiple OpenShift clusters, right, and have them all summarized in your general dashboard, but we have one per each provider. And then the topology widget where you see all the connection, all the relationship of the entities that we know about with their status, the color indicates their current status. And then there's one last thing that I want to show you, which is the timeline that was mentioned earlier, where we collect all the relevant events that happened in your cluster on the entities that we know about. Right here, we have all the events happened in this provider, and we can link and follow to the entities. We are working very much on this timeline to make it more scalable because we know that we have a lot of events coming in from OpenShift. So we'll see great improvement there with the ability of zooming in, zooming out, accumulate, aggregate events, and much more. So I want to point out something that is fundamental here, which is the fact that OpenShift is a very peculiar provider for CloudForms because it's actually living on other providers. CloudForms had the support for the providers that I'm mentioning down there, which I'm not able to point to, but what we added was the OpenShift provider, which actually lives on top of those virtual machines and instances. So not only we collect all the entities that I'm showing you there and much more, but with all the relationship and all the attributes and all the important information that you might need, and the metrics, of course. And not only you can follow the relationship of all those entities up there, but you can also cross to other domains, to other providers, finding out where a certain node for OpenShift is living in the underlying infrastructure. It might be an instance on Amazon, a VM on Rev, or an instance on OpenStack, and so on. And so you can leverage these relationships not only within the provider, but also using other information that you have in the other providers. So again, starting from the dashboard, we can reach the nodes. And from there, here, we see all the nodes of all the clusters that we are connected to. We just pick one, and we see right away up there that we have an underlying instance that was identified. And we can cross over and see what are all the information about this instance. And not only from the node we can reach this cross-linking, but we can also do it from all those entities that are living on a certain node, such as the pods. So you can see that the pods here report not only the node where they're running, but again, also the instance. And you can follow from there onto the instance. But again, so this is in the UI, but anything that is in the UI presented here, it is actually usable in the framework, in the management framework, which means that you can write any policy, alerts, and automation on top of that. So we mentioned alert a couple of times. I want to show you a couple of examples and define what they are. So they are notification of changes in the entities or threshold limit reach or notification of a threshold limit that has been reached. As Itamar mentioned earlier, you can send emails, SNMP traps, or visualize those in the timeline. You can also trigger an event that then you can chain to policies and automation. And again, all the information that is collected is usable here for you to create your own alerts. We'll see how it is easy to create a couple of these alerts. If you're familiar with CloudForms, obviously this is something that you already know about. You just go in the alert page. You see that there are several out-of-the-box available. So this one is about creating an alert about the VM disk usage higher than 90%. And again, since these VM that we are doing alerts against are the same nodes where OpenShift is running, the alert is relevant also for OpenShift as long as you mesh them together. So you have the ability with that editor to create logical expression that are evaluated against the attributes of the objects that are collected. Then you can send email. That was an example. This is the SNMP trap where you have a lot of custom attributes that you can set or show that in timeline. When this is ready, you can just add the alert and then match that, assign that to a certain provider. We'll add another one just as an example, for example, of a node that is non-responsive. Again, we just come up with a description. We set up a simple configuration up here. And again, we decide what to do on that alert. We have, again, a certain logical expression that we have to define. This is based on a certain field that we know. There are also relationships there as well, so you can also leverage those, as I mentioned earlier. You can send an email again. And that's pretty much it. So once again, mentioning the fact that all this information is collected and is provided to you to be used with different features. And another feature that is using these capabilities is the report. It's based, again, on the idea of the single pane of glass. You can do aggregation, slicing of the data, and once you define those, you can create reports that then are associated with a chart that you can display on the dashboard. You can attach these reports and these charts on your dashboard. So you can create the report that are more meaningful for you, for your use case, create charts and attach them in one of the dashboard. There are many that are out of the box in the initial dashboard that was shown at the beginning. We'll show you how to create a new report fully based on the information collected from OpenShift. So this is the dashboard that I mentioned. These are the ones out of the box. And when you connect the providers, after collecting some information, those are automatically generated for you. But again, you want to create your own. So you just go to the report section. you define the name and the entity on top of which you want to base that on. It will show you all the fields that you can use for the report. There are many because it is actually showing you also all the relationship, all the utilization data that we have. You select the fields that are categorized by the relationship, the hardware, and so on. So what we are creating here is a report of the distribution of the RAM across the nodes. So you might have multiple flavors of nodes in your cluster. We want to see how that's distributed. You can do the consolidation. We are going to pick one consolidation here. You can change the formatting. This is generally set correctly for you, but you can change that as you like. Style, again, also allows you to change the style of the report. You can do filtering so that you can filter out values that you're not interested in this report. Again, the logical expression editor that we know and that is used across the entire product. We do the summarization of the data. We define the sorting order. And then we define what is the chart type that we want to attach to this report. Once that's done, you can have a preview of how this report will look like and how the chart is looking like. So you just hit the button over there, and we have a small cluster here and the distribution of the RAM across the nodes. We just have 3 different flavors with this type of distribution across them. Another interesting use case that was already present in CloudForms for VM and instances is Chargeback. So we extended that to containers because as an operator, you might be interested in knowing what are the projects that are more costly to you in terms of resources and money as well. So based on the utilizations that we collect, we are able to associate those with rates that you define and use the reports to generate the chargeback reports that then you can feed inside of your billing system of your organization. Again, there's a section dedicated to chargeback, and that is where you define your rate. So as you were used to do that for VMs and instances, you can go there, define the rates, whether they're fixed or based on usage, for CPU cores, memory, and network. And then you define the assignments. So you assign these rates. You might have many different rates depending on the providers that you're connected to, and assign them to your container provider. Then you reuse the well-known report to generate a chargeback report based on the rates that you just defined and additional rules if you want to. Again, you fill in the name, you pick what is the type of report that you want to do, and in this case is the chargeback for project, of containers project. You're presented with all the fields. There are several fields that might be relevant to you. You can select all the ones that are interesting. You move them in the selected fields, and then you move on adding formatting and filtering. Once this is defined, it's a type of report that you have in your system. You can schedule this report to be running every certain interval. But for the sake of this presentation, we will just queue right away when the generation of our report. It takes a little bit to collect all the metrics, aggregating them up. And once they're all aggregated per project, we have the report ready. So we show also, obviously, all the projects that were removed from the system because they actually utilized resources while they were active. So if you do reports at the end of the month, you will still see projects that were deleted before the end of the month and that they used some resource in your system. Of course, running the containers is your primary concern, but you should not forget about the security. What you really want to avoid is to be running containers with vulnerabilities, and that is why we integrated with OpenSCAP for containers. We already had the smart state analysis implemented for images. We were able, and we are still able, to crack open the images, look at the content, RPMs. But now we extended that with the ability to run OpenSCAP on top of that, which is giving you a set of rules that are evaluated for the known CVEs, and you have a result for that, which is either failing or pass. And this information is collected by CloudForms, and again, you can do policies against that. CloudForms comes with a good policy out of the box, which is checking what are, if there's any rule of high criticity that failed, and in case there's any rule of that kind that is failed, it is actually marking the image as not compliant, both within CloudForms and in OpenShift, because basically we added a new action to the policy system that is able to annotate the images within OpenShift with a special annotation that says that this image failed the policy check on the CloudForms side. So let's see how this works. So first of all, we are going to explore the OpenSCAP policy that we have out of the box, which again has a logic over there that is evaluated on a certain event, which is the compliance check. That rule gets evaluated and an action is taken, such as probably sending an email to the security team and even marking the image as not compliant. So you go to an image, you trigger the smart state analysis. Once that's completed, you can go into the specific image and see what are the RPMs of that image, and even the results of the rules that were evaluated against that image. We have an history about the compliance check so that you can find out when the image was marked as not compliant for the first time, when it was evaluated to be not compliant. And then if you want to look at the report, the one generated by OpenSCAP, you can also do that because we are able to present it to you in the same manner that you're familiar with if you already are using OpenSCAP. That is a very dynamic report and very known, so I'm just going to mention another couple of things here. So you can, it's very dynamic. You're probably familiar with it. You can select what are the CVE that you're interested in. There are links to the CVE to how to resolve that. And it's generally really useful to look at these reports as well. And I'll give back to Itamar for the roadmap.
Thank you. Before we skip to the roadmap, any questions on what we showed so far? CloudForm orchestrate a pod on OpenShift to scan the images, yes. So OpenSCAP itself, it's container world, so OpenSCAP comes in an image, and we orchestrate that as just like any other pod on OpenShift to scan that image. It pulls it if it's not already in the cache of the host it's running on.
Yeah, there are 2 reasons, maybe even 3 reasons to do that, because you want to reuse your infrastructure as you do builds, also to do the scanning, so you can even scale those out for multiple scanning at the same time. And you want to use the same nodes that are enabled to reach those registries to pull those images and be able to scan those.
Today, CloudForms is separate from OpenShift, right?
CloudForm, it's 2 different products, but when you buy OpenShift, you get CloudForms licensing-wise for OpenShift. The idea is that CloudForms will come out of the box as the management system for OpenShift. For that, as part of the roadmap, we're working on making CloudForm run in pods as well. And then as part of deploying OpenShift, it'll just be part of your infrastructure. Okay, let's skip to the roadmap. So, the obvious disclaimer, everything you see here, right? Don't quote us on it. It's roadmap planning and work, may change, etc. So I want to put much more focus on the life cycle of the OpenShift cluster. Okay? If you have CloudForms, you want to deploy a new OpenShift cluster, add a few clusters, add nodes to cluster, evacuate node, move them to maintenance, upgrade them, all those operations. Right now, you can do from command line, and we want to add the ability to do those through CloudForms. This is how it currently looks like. So the nice thing about CloudForms, that if you want to deploy something, it knows how to provision things, right? So we can go and look at existing providers, but we can also add providers. These would be OpenShift providers. And when we add a new OpenShift provider, we can choose if we want to add it from existing virtual machines, we want to provision new virtual machines, or we don't have virtualization infrastructure, we just want to try it in the lab. Let me just type here a few nodes myself. This is what we'll do here. We'll specify manually a few nodes, giving credentials to access those nodes. Those would be existing nodes, not nodes that we'll be provisioning. And as we add them, we can choose which roles they have. So do we run etcd on them, Kubernetes, can we use them for infrastructure tasks, or they're just plain nodes, plain slaves that we run? Can we use them for storage, etc.? So we can choose which roles we want to use on them. So we'll be adding 3 nodes to the system. The first one had all the roles on it. The second one is a plain node, but it's also an infrastructure node, so we can some tasks run on it as well. And the third node will just be a node, so only user workloads will run on it. So we can see the totals down of different types of nodes that we have, change the roles that we want, make sure that we chose the roles that we want to deploy. If we'll provision them, we'll basically won't do it one by one. We'll say we want 10, we want 3 masters and 10 nodes, right? Choosing the content, where do we want the RPMs come from, CDN or satellite, different authentication capabilities. You can do OpenShift supports all of those, so you can just configure the ones you want, LDAP, GitHub, or just create your own .ht user. So we'll be creating 2 local users as part of the deployment. Again, these features are OpenShift features. We're just provisioning this, so this is basically a GUI to install OpenShift. Storage configuration, we want persistent storage for the registry that we're going to deploy or for the ocular metrics that we're collecting. We can choose an external one or point to a local one, which is recommended for POC, review the deployment, and hit deploy. This is not in what we just GA'd yesterday. Okay, this is not what we GA'd yesterday. This is roadmap. So this is actually code that we have upstream and running, but it will but it's not in 4.1. It's worked towards 4.2 with all the disclaimers that I mentioned. Okay. Other things that we're working on, I mentioned that the service designer that we have in CloudForms, so we'll be looking at adding container entities to it, mainly OpenShift templates. We don't want to get into all the details of building an application. This is what you use OpenShift for. CloudForms is about consuming those templates. So you can create a service. There's templates of VMs, templates of OpenShift services, etc. I mentioned running CloudForms itself in a container in pods, so you can run it on the same infrastructure that we manage. It doesn't have to, oh, I want a container-only environment, suddenly I need a virtual machine. We'll also make deployment nice, with the exception if you want to deploy OpenShift from CloudForms, it needs to run on it. There's a chicken and an egg deal. We'll solve that. We have the OpenShift dedicated team. So OpenShift comes if you in the developer version, which is the OpenShift local and the OpenShift container platform. You can deploy it yourself, or you can get it as a service from Red Hat, which is called OpenShift dedicated. We also have OpenShift Online, which is just a service, which is a public service for everyone, versus dedicated, which is your own specific isolated service. Through those teams of OpenShift dedicated and OpenShift Online, we have tons of operational experience of what it means to run OpenShift. What alerts do we need to pay attention to? Which actions do they take? Things like that. So we're going to take that and push it. So CloudForms is not only a platform that you can do a lot of things off, and some of that is already out of the box, but we'll be adding much more of that knowledge into out-of-the-box platform. We already got some feedback on the Chargeback and OpenSCAP, so I want to extend the capabilities there. And common logging. Common logging is the project in Red Hat to basically, we showed that when you run a container in OpenShift, you can see the logs of that container. Basically, what we want to do is to be able to show you the logs from the infrastructure as well. So common logging is about configuring the different hosts in your infrastructure, your Rev, your OpenStack, etc., all sending the logs to a central logging service based on Elasticsearch, and the ability in CloudForms to show you per entity the metrics of the amount or trends in errors or types of events that happen there. So if you'll be able to detect in CloudForms there's an issue and drill from there into the logs relating to both container errors, logs, and infrastructure logs. That's it. Any other questions? Yes?
Can CloudForms, even if it's a feature, help you with the bare metal install? Let me give you an example. Say I just laid down RHEL on bare metal. Can I federate it with CloudForms and then have it lay down the rest?
Yes. So CloudForms supports bare metal provisioning via satellite today. So what you do is you go to satellite, you deploy bare metal with a discovery image of satellite, which creates discovered bare metal hosts in satellite. Then CloudForms can provision to those discovered satellite images and deploy OpenShift on them, basically.
So do the rest of the provision in like the Yum, Docker install?
Yes, it will. Yes, satellite is the bridge to talk to bare metal machines by having them discovered, or if they're already provisioned, they will still show up in your inventory. Satellite is that layer.
So that's supported already today?
That is, yes. Bare metal provisioning of CloudForms satellite inventory, basic provider support for satellite exists in CloudForms today. Okay, thank you very much. Hope you enjoyed Summit, enjoy the party.